Hi, sixth years. I hope you're getting on okay. I'm going to start by correcting the homework, the other two probability questions that I assigned to you on Tuesday. So, a survey of 168 people was carried out, and participants were asked whether they owned a cat or a dog, and some of the results are recorded in the Venn diagram below. Of those surveyed, 19 did not own either a cat or a dog. So let's pop that onto our diagram straight away. 19 goes out there. And the total was 168. So we can work out the section of people who owned cats only by subtracting these three numbers, 19 plus 64 plus 48, from 168. 19 plus 64 plus 48 gives us 131. And 131 from 168 is 37. So we have 37 out here. Okay, so we've completed the diagram. Now, we know the total, and that's going to be important for the probability questions that are following on. A person is chosen at random from those surveyed. What's the probability that they owned both? So both means intersection, a cat and a dog, and we're talking about the 64 in here then. So the probability of a cat and a dog, you don't need to do the set notation, is going to be 64 out of 168, and we will go ahead and just check if that simplifies. It should, because they're both even. That's 8 out of 21. 8 out of 21. What percentage of the people surveyed owned one animal only? So one animal only means that it's not in the intersection. We're talking about these two crescent moon shapes that are out here. And that is going to be 37 plus 48 divided by the total, and then multiplied by 100, or 100 over 1, to change it to a decimal. And that's 37 plus 48 divided by 168 and multiplied by 100. And they said, give your answer correct to one decimal place, so that's 50.6. 50.6%. Now, that's all of part one, working with sets. So hopefully that was familiar enough to you. And of course, as usual, let me know if you have any questions. A tree diagram in the next question. Mandy wants to buy a ticket to the theatre. She can choose a ticket for the balcony, which we're representing with the letter B, or the stall, which we're representing with the letter S. Mandy can go on Monday, Wednesday, or Friday. For an extra charge, she can choose a VIP ticket. Okay, so there's the day she can go, whether she goes to the balcony or the stalls, and whether she gets a VIP ticket or show only. And they've used the different letters there. They've shown you how they'll be illustrated on the tree diagram here. So the first choice is balcony or stalls. That's the location. The next choice is the day. And the final choice is whether she meets the band or not, whether she gets a VIP or show only. Okay, so we know that we should have, by the fundamental principle of counting, 2 by 3 by 2, which is 12 outcomes, if we do this right. Now, they want us to complete the tree diagram, and we can assume that all outcomes are equally likely, which means we don't have to write the probabilities over the branches like this. We can, when we list our outcomes at the end, there'll be 1 in 12 for each of those, because they said that all choices are equally likely. So let's complete this diagram here. If she goes on Wednesday, she could have VIP or ordinary. If she goes on Friday, she could have VIP or ordinary. If she goes to the stalls, we've got all the same outcomes again. VIP or ordinary. Oh yes, Monday, Wednesday, and Friday, VIP or ordinary, VIP or ordinary. Now, they didn't give you space to do this, but I've told you that our tree diagram is not complete until we write down our outcomes and their probabilities. So we're going to write down, let's just double check, we should have 12 outcomes here. So outcomes and their probabilities. So if we count them up there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 outcomes. So we're fairly confident that we've done this right. This one is balcony Monday, VIP. Balcony Monday, show only. Balcony Wednesday, VIP. Balcony Wednesday, show only. Balcony Friday, VIP. Balcony Friday, show only. Stalls Monday, VIP. Stalls Monday, show only. Stalls Wednesday, VIP. Stalls Wednesday, show only. Stalls Friday, VIP. Stalls Friday, show only. And each of those probabilities is 1/12. I didn't leave a lot of space. 1/12, 1/12, all the way down. Because they're equal, you probably could get away with not filling in the probabilities here and still be able to work this out perfectly fine. So this is just to help us. Now, if this was your exam paper, you might decide to ask for extra paper to fill in something like this. If you want more space for a question, just label it clearly, and that's fine. You don't have to answer on the sheet if you need more space than they've provided. Complete the tree diagram below and hence or otherwise find the probability that Mandy chooses a VIP ticket on Wednesday. So she could choose a VIP ticket on Wednesday on the balcony, or she could choose a VIP ticket on Wednesday through the stalls. These guys are the Wednesday options. So there are 2 out of the 12 options there. So the probability of being VIP and Wednesday is 2 out of my 12 options, which is 1/6. And that's how we could do it. Okay, right, I'll move on. So that would be a little bit time consuming, a question like that, doing out the full tree diagram. Now, when taking a penalty kick, the probability that Kevin scores is always 3/4. Kevin takes a penalty kick. What's the probability that he doesn't score? Well, it's going to be 1 minus 3/4, which is 1/4. He takes 2 penalties. What's the probability that he scores both? So just to help myself now, I'm going to say the probability that he scores is 3/4, and the probability that he does not score, you could use M for misses as well. It's just handy to have a letter to represent the events that we're talking about. So he takes 2 penalties. The probability that he scores both, he scores and he scores again. So remember, both means and, which means multiply. So he scores the first and he scores the second, and that is 9 out of 16. Kevin takes 3 penalties. What is the probability that he scores exactly twice? So first of all, we need to write down the ways he can score twice. And he could do that by, now it's exactly twice, so we can't allow him to score 3 times. He could score the first 2 and miss the last, or score the first and the last, or miss the first and score the other 2. So those are the 3 ways that he could score exactly twice. And when we're doing the probabilities, it's the probability that he does it this way, or means and, the probability that he does it the second way, or the probability that he does it the third way. These guys in here, he scores and he scores and he misses. He scores and he misses and he scores. He misses and he scores and he scores. So you can hear him saying and there, which means we're going to be multiplying our answers. He scores 3/4, 3/4, 1/4. These are actually all the same because multiplication is commutative. We're keeping ourselves honest by doing it like this. So then type that into your calculator. I'm actually going to just type it in once and then multiply it. So I'll have 3/4. You might find it more convenient to type in 0.75. 3/4 and 1/4. Okay, and then I'm going to multiply that by 3. So 27 out of 64. And that's the probability. Now, here's our Bernoulli trial. Kevin takes 5 penalties. What is the probability that he scores for the first time on his 5th penalty? So this means we're looking for the probability that he misses the first 4 attempts, but succeeds on the 4th one. So 1/4 multiplied by itself, you can use a power here if you want, if you spot that, and then multiplied by 3/4 gives us our probability. So we have 1/4 multiplied by itself 4 times, multiplied by 3/4. Now, I hope you realize that I've typed in the same thing as I've written down there, but you can do it the long way if you prefer. And that gives us 3 out of 1024. It's fine to leave it like that. So you can see that's quite a small percentage. It's not even a full percent. It's about a little bit less than 1/3% of a chance of that happening. Okay, so I said we'll have a test in probability next week, and I think maybe Tuesday or Friday. I do want to get a good run on geometry before I do it. Anyway, I'll have a think about it and I'll let you know over email or Google Classroom. Right, we'll have some geometry notes coming next. Thank you.